Good morning to everyone. Today I discuss the three-phase inverter. So when the power requirement is high, three-phase inverter are used. When the power requirement is high, okay. When the power requirement is low, the single-phase inverter is used, and when the power requirement is high, the three-phase inverter are used. Okay, so three-phase inverter is needed when three-phase output is required. Okay, three-phase inverter is used when three-phase output is required. Okay, what is a three-phase inverter? Now when a three single-phase inverter connected in parallel, when a three single-phase inverter means this is a single-phase inverter, this is a single-phase inverter, and this is a single-phase inverter connected in parallel. Okay, this is the single phase, this is the single phase, here also a single phase, and here also a single phase. Okay, when the three single phase, one single phase, second and third, when the three single phase inverter connected in parallel manner, connected in parallel, is called the three phase inverter. Okay, three phase inverter. When single phase inverter connected in parallel, when three single phase inverter, three single phase inverter connected in parallel is called the three phase inverter. Okay, three phase inverter, there are two types of mode. There are two types of mode available for three phase inverter. First is 180-degree mode, 180-degree mode, and second is 120-degree mode. We first discuss the 180-degree mode. Before we discuss the 180-degree mode, there are what is a three phase. Okay, there are three terminal A, B and C, and this is the neutral terminal. There are phase difference between A and B is 120-degree. Their phase difference between B and C is also 120-degree, and the phase difference between A and C is also 120-degree. So the total phase difference is 0 to 120, 120 to 240, and 240 to 360-degree. So the total phase difference is in a three-phase circuit is 360-degree. There are three types of phase: between A and B, between B and C, and between C and A. Between A and B 120, 0 to 120, between B and C 0 to 120. Okay, between B and C 120 to 240, between C and A 240 to 360-degree. Okay, here we discuss the 180-degree mode of three phase inverter. There is a single three phase inverter, this is a single phase inverter, this is a single phase inverter, and this is a single phase inverter, and this inverter is connected in parallel. Three single phase inverter connected in parallel. So this terminal is called A, this terminal is called B, and this terminal is called C. So A, B, C connected in parallel, and the SCR is called, this SCR is called A T1, and this is called the T4. So A terminal is connected between T1 and T4, and B terminal is connected between T3 and T6, and C terminal is connected between T5 and T2. Here the load, this is the star connected load. Okay, this is the star connection. Star connected load is across between A, B, C. Is a star connected load is connected across between A, B, C. This is the A point, this is the A point, this is the B point, because the B is connected and here the C is connected, so this is the C point, and this is the neutral point N. And impedance Z is connected, star connected load. Here Z is called the impedance. Okay, so here are some points. First point is there are 6 SCR. Okay, there are 6 SCR. Wings A T1 and T4 are connect. Okay, connect. Wings B, T3 and T6 are connect. Okay, and wing C, T5 and T2 are connect. Okay. Second point is here, for simplicity, not connected commutation and protection circuit. For simplicity, not connected commutation and protection circuit of SCR. Okay. Next, why it is called the 180-degree mode? Because each thyristor turn on for 180 degree. Each SCR is turned on for 180 degree. In 180 degree mode, okay, we need to turn on the SCR for 180 degree. Means for each SCR turn on 180 degree. For each SCR is turned on 180 degree. After 180 degree, the SCR is turned off. So a SCR is turned on between 0 to 180 degree. Its minimum is 0 and maximum is 180 degree. After 180 degree, this SCR will turn off. So it is called the 180 degree mode. Okay, first here some discussion over here. First, wings A. First consider wings A. This consider wings A. So start from 0 degree. First T1. Starts from 0 degree to 180 degree. So from 0 degree to 180 degree, turn on T1 for SCR T1. From 0 degree to 180 degree, turn on T1. After 180 degree, T1 is off and T4, because the A is connected between T1 and T4, and after 180 degree T4 is on. Okay, after 180 degree T1 is off and T4 is on. So next 180 degree the SCR T4 will turn on. T4 is on for next 180 degree. Okay, so each SCR is turned on for 180 degree. So T1 this is the 0 degree, this is the 60 degree, this is the 120 degree, this is the 180 degree, this is the 240 degree, this is the 300 degree, and this is the 360 degree. So for wings, this is the wings A, this is the wings B, and this is the wing C. First we consider the wings A. 0 from 0 to 180 degree turn on SCR T1. So 0 to 180 degree means 0 to 180 degree. This is the 0 to 180 degree. This. So 0 to 180 degree turn on SCR. So this for SCR T1. Okay, this is for SCR T1. Okay, T1 is on. Okay, and next after 180 degree to 360 degree turn on T4. So after the 180 degree, the T4 is turn on. So T4 is on between 180 degree to 360 degree. Okay. Next, for wings B. So this is the wings A, this is the A, and this is the wings B. Between wings B started from 120 degree, because the wings A started from 0 degree. So wings B is started from 120 degree. So 120 degree out of phase with respect to wings A. Okay, 120 degree out of phase with respect to wings A. So after 120 degree, okay, T3 turn on, because the wings B is connected between T3 and T6. After 120 degree, T3 is turn on and conduct up to 180 degree, turn on for 180 degree, and after 180 degree, T6 turn on for next 180 degree. Okay, so two thyristor is for 360 degree, one thyristor is for 180 degree, and after another thyristor is used for next 180 degree for each wings. So because the 120 degree out of phase with respect to A, so after 120 degree the T3 will turn on. So after 120 degree means this is the wings B. So after 120 degree, this is the after 120 degree, because A and the phase difference between A and B is 120 degree. So after 120 degree, T3, after 120 degree, T3 will turn on for 180 degree. So T3 is turn on for 180 degree, 60, 120, and this is the 180 degree. Okay, so this is 60, 120 and 180. So it is for T3. Okay, this is for T3. Next, T6. Next, after 120 degree, T3 will off and T6 will on. So after 180 degree of T3, T6 will on for next 180 degree. So T6 is on. Next, here T6 is on. T6 is on for 180 degree. So this is 60, this is 60, 120 plus 60 means 180 degree. So here T6 is turned on for after 180 degree of T3. This is the 60 degree, this is the plus 60 degree means 120 degree, and this is the 180 degree. So this is also for T6. Okay, this is also for T6. So this is for wings B. And next, wing C. What is wing C? Because it is starting from 240. Wing C is starting from 240. So 240 degree out of phase with respect to wings A. Wings A means after 240 degree wing C is activated. For 0 degree wings A is activated. After 120 degree wings B is activated. After 240 degree wing C is activated. So wing C, there are two ACRs connected, T5 and T2. So first T5 is turned on for 180 degree. Next T2 is turned on for next 180 degree. So here T5 after 240 degree T5 turn on for 180 degree. After 180 degree T2 turn on for 180 degree. After T2, T5 is turned on 180 degree. After 180 degree, T2 is turned on and T5 is turned off. So it is starting from 240 degree. It is starting from 240 degree. 240 degree. So first 240 degree, T5 will turn on. So this is the starting point. So this is 60, this is 60, 120, and this is 60 is also 180. Okay, this is 60, this is 60, 120, and this is 60, 180, because each SCR conduct up to 180 degree. So this is for T5. Okay, this is for T5 and it also for T5. Okay, because 60 plus 60, 120 plus 60, 180 degree. Okay, after 180 degree, T2, after 180 degree, T2 will conduct. So T2 is starting from this 60 plus 60 plus 60. This is for T2. This is for T2. So this is the operation. This is the operation of three-phase inverter. This is very simple. Okay. This is the operation of a three-phase inverter. So wings A is starting from 0 degree, wings B is starting from, wings A is starting from 0 degree, wings B is starting from 120 degree, and wing C is starting from 240 degree. So when wings A is connected between T1 and T4, so from T1 is conduct from 0 degree to 180 degree, and T4 is conduct after 180 degree to 360 degree. For wings A, in wings B T3 is start from 120 degree, because the phase difference between A and B is 120 degree. So after 120 degree, T3 will start on for up to 180 degree. After the 180 degree, T3 is turn off and T6 is turn on up to 180 degree. This is the wings B. Next, wing C. Wing C is 240 degree phase difference with respect to A. So after 240 degree, T5 will turn on for 180 degree. After 180 degree, T5 is turn off and T2 will turn on up to 180 degree. So first T1 is turn on for 180 degree and T4 is turn on for 180 degree for wings A. For wings B T3 is start. T3 is starting point because 180 degree out of phase, because the wings B is 180 degree, so starting point is 180 degree. So T3 is conduct for 180 degree and starting from 120, because the phase difference between 120. So this is the starting point of T3. Okay, so 60 plus 60 plus 60, so total is 180 degree. T3, after 180 degree, T6 will turn on. So this is the T6 turn on for 60 plus 60 plus 60, total 180 degree. Next, C for 240 degree phase difference. So starting point is 240. This is the starting point of C and this is the starting point of B. This is the starting point of C. So T5, first T5 is turn on. So T5 is for 60 plus 60 means 120 plus 60. So 180 degree. After 180 degree, T5 turn on and T2 is turn on. T2 is starting from this 60 plus 60 plus 60, 180. This is the working configuration or working principle of 180 degree three-phase inverter. And next day we discuss the calculation and waveform of 180 degree mode three-phase inverter. Okay. Thank you.